Hello everyone, welcome back to Educately Geography. Today we're going to be talking about natural disasters, so let's get started. Today's objectives, we're just going to first of all define what natural disasters are. Then we're going to talk about how certain natural disasters occur, just give some examples, and then give even more examples of specific natural disasters that have occurred and that have done a lot of damage historically. So first, what are natural disasters? Natural disasters, as the name suggests, are major events caused by natural processes. The actual events that occur to cause natural disasters depends on the type you're talking about, but it's a pretty self-explanatory term. It can be used to describe weather as well as other natural phenomena. It doesn't necessarily have to be weather. Examples, the ones that we're going to talk about in this video are volcanic eruptions, earthquakes, tsunamis, hurricanes, tornadoes, blizzards, and floods. There are other examples, but these are like the most prominent types, and these are the ones we're going to be talking about in today's video. So first we're going to talk about volcanic eruptions, earthquakes, and tsunamis. Those three are relatively intertwined. And before we get into that, I think it's important to talk about the Ring of Fire. The Ring of Fire is a location. It's roughly around the Pacific coastlines of like Asia, North America, South America. It does extend about a bit into the ocean around Australia, not very close to it. And it's basically just an area that's characterized by high volcanic and seismic activity due to the structure of tectonic plates there. And well, first we're just going to talk about volcanic eruptions and how the tectonic plate formation around the Ring of Fire might influence volcanic eruptions in that area. So volcanic eruptions happen when magma, which is just melted rock from the Earth's mantle, which is a layer in the Earth, rises to the Earth's surface. So it can like get through certain seeps and cracks. It can seep through like cracks in the Earth's crust, make its way to the surface. There are some examples of historic volcanic eruptions. For instance, Mount Vesuvius in Italy in 79 AD. If you haven't heard about it, in Italy, it basically just buried the city of Pompeii and other nearby towns, completely preserving somehow like all the people that were living there. And now it's a very popular site because of how life was preserved there in a sense. Krakatoa in Indonesia, this was known for its intensity. This eruption occurred in 1883, and it was so loud it was heard 3,000 miles away from where the eruption was. It was a very intense eruption. So now going back to the idea of like the Ring of Fire and like why maybe that area is prone to volcanic eruptions, we're just going to talk about how volcanic eruptions happen and how volcanoes form. First of all, they often form at divergent tectonic plate boundaries. These are plate boundaries where tectonic plates are moving away from each other. So as you can imagine, if you have like two land tectonic plates and they're moving away, it gives some room for like magma underneath the Earth's surface to just rise up and just come through the surface, which is what a volcanic eruption is. However, in the case of the Ring of Fire, what happens is that there are subduction zones that form. Subduction zones happen when it happens in a specific instance where two plates converge, specifically when one of them is an oceanic crust and the other is a continental. In this case, the oceanic crust kind of like subducts or goes underneath the continental crust. That's why it's called a subduction zone. And when this happens, the oceanic crust, the crust has some sort of water type minerals in there that get released into the area below the continental crust. And this water then seeps into the mantle where it lowers the melting point of the rocks around it. And then because it's very hot underneath the Earth, as you can imagine, those rocks start melting. And that's how magma is produced. And eventually that magma can just seep through cracks in the crust and into the diagram shows it pretty well right here. It just seeps through and then it can leak onto the surface. There's a third way volcanoes can form, like in places called hotspots. They're not related to tectonic plates, we don't know how they are related to them. They don't necessarily occur near fault lines. These are relatively unknown. An example of it is Yellowstone National Park. So that was just to give you some insight on how volcanoes form. Next up, we're going to talk about earthquakes. You can see example of some of the damage that earthquakes cause. They can be very destructive when they are strong. They occur when stress along fault lines or sometimes even within tectonic plates, not necessarily near fault lines. Usually it's near fault lines though. Stress is released in vibrations that are what earthquakes are essentially. The strongest earthquakes happen usually at subduction zones, which is, as I mentioned, it's where the oceanic crust it converges into a continental crust and goes underneath. But other strong earthquakes have happened at convergent boundaries where two tectonic plates collide directly into each other, and also at transform boundaries. We haven't talked about this one so far in this video, so I'll just highlight it to the side. It's basically when two tectonic plates, usually land plates, they like grind past each other. They go in like parallel directions, like opposite directions, but they don't necessarily collide into each other. A good example of this is the San Andreas Fault in California, or it goes up the west coast. It's very prominent in California, and it has caused a lot of earthquakes in that area. For instance, there was a major earthquake in 1906 in San Francisco, another one in 1989. Both were caused by that type of plate boundary. More about earthquakes, and the strength of earthquakes is it's measured on the Richter scale. So the Richter scale, I have a diagram right here to the right. Basically, it's like from 0 to 10, and the way it works is that each successive number it represents 10 times more shaking than the previous one. So if you have a magnitude 7 earthquake, that means it has 10 times more shaking, and as you can see with this diagram, 33 times the amount of energy released compared to one of magnitude 6. And that's a relationship. Basically, it's not a linear relationship. Like the difference between a 9 and an 8 on the scale isn't the same as like an 8 and a 7. It rises in a non-linear way. So some examples of historic earthquakes: the 1960 Great Chilean earthquake. It's the strongest earthquake in recorded history, magnitude 9.6. Another one is the 2004 Indian Ocean earthquake, 9.1. We do occasionally get earthquakes that are above 9. It's relatively rare. Usually on a yearly basis, we only get one that reaches around magnitude 8, magnitude 7, or a few that get to magnitude 7. Magnitude 9 is relatively rare. 9.6 is the highest we've ever gone. Tsunamis, they're often a byproduct of earthquakes and volcanic eruptions. They're basically massive waves that are created by those. Sometimes they can be created by large objects falling into the ocean also. So if there was like a landslide that caused a massive splash in the ocean, like say an island just fell into, like a part of an island collapsed into the ocean, that could cause these massive waves to form. There are a lot of warning signs with tsunamis. First of all, strong earthquakes. If there's an earthquake and you're near a beach and that earthquake it happens around a fault line that is known to cause tsunamis, it's usually a warning that if you're near that beach, you should probably evacuate towards higher ground. Usually they will issue tsunami warnings before a tsunami hits, but it can come very quickly, like in the matter of like 10 minutes. They are pretty quick, so it's important to listen to warnings. Right before tsunamis, the ocean usually recedes. So if you're at a beach and a tsunami is about to occur, the large wave kind of causes like the ocean part near like the beach to just like seep back into the ocean. So the ocean can just like recede. It's a very odd sight. Sadly, that means a lot of people often go to beaches to like check that out if they're not aware of that danger. They just unsuspectingly just check that out, and then they get stuck in the tsunami. Also, right before a tsunami, usually there's like a loud roar because of the massive wall of like the wave that occurs, and also there's like a wall of water that's just the size of the wave. This is an example of of multiple of the warning signs that I just talked about. First of all, the ocean, as you can see, is like clearly receded. Usually it looks like it was probably going to end here, but it's receded all the way back there. It's pretty shallow. You can see like deposits of sand. And you can see, like, if you look closely, a massive wall of water. And it looks a little small if you look at it from here, because this picture was taken relatively far away. But those those ships almost like certainly sunk and capsized as a result of that wave. That's a very big wave. They are very dangerous waves. More about tsunamis, you can see some of the destruction that tsunamis have caused, and then this is one as hitting the shore. Example is the 2004 Indian Ocean tsunami. It was caused by the earthquake we talked about in the last section, the Indian Ocean earthquake. It was caused by the magnitude 9.1 earthquake. It was heavily just immense death. It was 250,000 people died as a result. A lot of people, this was in the Indian Ocean, so a lot of people in a lot of different countries also. Many of them were tourists because this happened during like around the time of Christmas. A lot of Westerners and other people just traveled to these resorts on islands, and they weren't necessarily like suspecting much about it and just a severe tsunami. Local communities and economies were devastated as a result because these communities were just ravaged. Hurricanes and typhoons are the next on this list. They form when warm ocean water evaporates quickly, which creates like a spinning storm. So it's like warm ocean water and like air right above the ocean in summers usually because that's when it's the warmest, especially in the northern hemisphere. That air is going to evaporate, and as warm air, so warm water evaporates, warm air goes up, cold air higher up in the atmosphere, it's going to start causing a spinning motion to occur because that warm air is going to cool and that it's going to go back down, creates a cycle. Hurricanes are divided into numerous categories based on maximum wind speed. Here's a chart that represents the scale. It's known as the Saffir-Simpson scale, but it's not really referred to that name as much because there's only like one prominent way to talk about hurricanes. So there are some examples of strong hurricanes that have occurred typically around the United States. By the way, hurricanes are called typhoons if they occur usually in the eastern hemisphere, so in like the Pacific Ocean towards Asia. That's what usually people from like Asia call them. Other parts of the world, hurricane's a more North American name. So examples of hurricanes, first of all, you have Hurricane Katrina that occurred in 2005 in the Louisiana area, devastated New Orleans and nearby communities, killed over 1,000 people. It's tied for the most damaging hurricane in modern history and recorded history. The Galveston hurricane, I believe it's one of the deadliest. It's even deadlier than Hurricane Katrina. It occurred in 1900. Ravaged communities in Texas. Galveston is in Texas. I believe Hurricane Katrina was a Category 5 or 4 or 3. It was up here when it hit Louisiana. Galveston, I'm not sure what the category was, but it was also presumably pretty strong. Yeah. Next up, we have tornadoes. Tornadoes, the process by which they form is a little complicated, but basically it's kind of similar to like hurricanes if you think about it, because it's warm air, it horizontally cycles with cool air. So, the warm air rises, but then it falls back down because now it's cooler. And then it just cycles around with cool air in like a horizontal spinning fashion. At the same time, though, these occur over land. And when you have a thunderstorm, sometimes you have a strong updraft. And as you can see with this diagram, you can see the spinning cycle that occurs right here. I'm sorry if the thing's getting in the way. But basically this updraft, it causes that spin to kind of go vertical. And because of that, that can form a funnel that makes contact with the ground, which is what a tornado is. It's like a funnel from the clouds that makes physical contact with the ground. It can cause intense winds. The actual scale and magnitude of the strength of different tornadoes is measured by the Fujita scale. It can cause terrible winds up to 300 miles per hour. And an example of that is the 2011 Joplin tornado, which reached this is F5 now, it's known as EF5. It had winds of over 200 miles per hour, well over that. It was extremely deadly. Again, 158 deaths, over 1,000 injuries, $3 billion of damage, and yeah. Usually they do occur in outbreaks. Sometimes you have certain situations where like tornadoes are more likely to occur than others. And they do occur, I think, throughout the world, but they are very prominent in the United States, especially in the central portion where they call it Tornado Alley. But they can occur in various locations, even if they typically don't get it. You just need the right conditions for them to form. Next up, we have blizzards. Blizzards are classified as snowstorms with 35 plus mile per hour winds and whiteout conditions. Whiteout conditions usually means that you can't see more than 1/4 of a mile away as a result of how snowy and windy it is. It's just like barely visible. If you've ever been outside during a blizzard before, you know what it's like. You just can't see anything. And that's where the wind part comes in. Usually for that to happen, it has to be extremely windy. So usually the National Weather Service has said that speed is 35 plus miles per hour. Also, these conditions have to be present for more than 3 hours for a snowstorm to be classified as a blizzard. So it occurs when warm air rises over cold weather at the surface. So that's typically how precipitation forms. It's just in the form of snow, and if that temperature difference, is often very severe, that can cause even more severe conditions. It's interesting to note though that blizzards don't necessarily have to involve there being like actual active snowfall. They can actually occur if there's just a lot of snow on the ground and like high winds are just picking up that snow and causing it to be in a near whiteout condition. The conditions are still the same, but notice how the conditions don't talk about how much snow has to be falling. So those are usually called ground blizzards, where there's no actual snow, but it's just wind is causing the snow on the ground to get picked up, and you can't really see anything. So yeah. Last, we're going to talk about floods. Floods generally happen when excess water cannot be carried out quickly enough. So there's like a reason that there's a lot of water in an area and it just can't get drained into it could get drained into like a nearby lake or river or a different water source, but like it just happens too quickly and the natural water system can't deal with like that excess amount of water. It impacts low-lying areas the most because, as you know, water flows downhill. So if you have a lot of water somehow in an area, say it rains a lot or a lot of snow is melting, that water is automatically going to flow downhill, and that's how it kind of just pools in a sense if it happens really quickly, and it just causes flooding. Frequent causes, I just mentioned heavy rainfall and also melting snow and ice. So if that happens too quickly, that just overwhelms the natural ways water gets drained into different bodies of water. It also happens a lot there. Like a lot of severe floods have happened because of broken dams. Basically, dams hold water in a certain way, and if a dam breaks, all the water behind the dam can explode, like not explode, but like flood out into the neighboring areas where there's no water, and like communities have been established, and it just destroys those communities. Here I have a picture of a flood in China from 1931 from the Yangtze River. The cause of this flood was they had 2 years of drought, and then they just got a lot of cyclones, typhoons that just ravaged the area with water. They had a lot of snow that melted from the mountains from the winter before. And just a bunch of conditions led to this terrible flood. There's conflicting reports on how many people died during that flood. Some state that it's around 400,000, while others have stated up to 4 million people. It's considered the deadliest flood in modern history. So yeah, these floods, again, like other natural disasters, they can like just kill a lot of people. It's scary, and you have to, especially in modern times, you just have to be careful and just find ways to listen to like experts before there is a flood and just be safe. That was grim, but thanks for watching this video. I know it was a longer video. There was a lot to cover. If you have any questions or if you want to watch any other videos on geography, feel free to browse through our site. We have tons of other subjects here at Educately, but that does it for now. So until then, thanks for watching and see you guys.